Okay, the continuous growth formula. So in our application, sometimes this big keyword continuous is going to come up. What that's pointing you towards is this formula that has the E involved. Now, E is what we're going to treat as a number from here on out. This very famous mathematician by the name of Euler came up with this number. Kind of cool, right? Well, this number is approximately 2.7182, etc. All right, but in this formula, as we kind of break it down, A is going to represent the starting amount, much like it did with our compound interest, but this is continuous, so that's the big keyword we're going to be looking for. All right, if you see continuous, go to this formula. R is going to be our continuous growth rate, and we have to be a little bit careful. Things can get larger continuously, in which R is going to be positive, or things can decay or get smaller over time, in which case R is going to be negative. Now I went ahead and I brought up this other formula that's used more so in banking, where P is the starting amount also. It's called the principal in banking problems. A is the accumulated amount, like what you end up with. E is a number, R is rate, and T is time. So you may have seen the same formula, just written with different letters in the past. To get to E on our calculators and to be able to utilize this, it's going to be located up above the natural log button, the ln button. So to get to that, what you want to do is you want to push either second, or on some calculators it's shift instead of second. All right, to get to any of these symbols that are located up above. But if you push these buttons, it should come up with, on my calculator it looks like this, and it starts a set of parentheses. On more modern calculators, it goes E, and then your cursor will be up in the exponent automatically. So let's work on a problem with this. Let's try radon 222 decays, keyword there, at a continuous, another big keyword that's pointing us towards the right formula, at 17.3% per day. All right, how much will 100 milligrams of radon 222 decay to in 3 days' time? All right, so kind of lining up the components of our formula. The first thing is we'd like to know how much do we start with. All right, well, it tells us we have 100 milligrams. So that's going to be a value for our A. So 100, and this will be in milligrams. So our solution, what comes out of this formula, is also going to be in milligrams. All right, now other components are we need our rate. Well, they tell us it's 17.3%, but it's decaying, so that needs to be negative. The other thing we need to do with this is we need to move 2 decimal places over and make this into a decimal that's equivalent to this percentage. So negative 0.173 is going to go into our formula. And on this one, they also tell us how much is going to be left after 3 days. Well, that's typically a value for our X, or our time, if you were using the right formula. All right, so that's 3 days. Our rate was also in days. So that lines up, which is nice. So our function can be f of 3 equals our starting amount, then e raised to the negative 0.173 multiplied by, I'm using that star to indicate multiplication, 3. All right, when you put this into your calculator, I would have to start a set of parentheses here. That would automatically get started, but I would want to stop my parentheses after the 3. Your calculators may be different, but that's why it's important to practice with these to get really comfortable with your calculators. Now, because this is decaying, we'd expect to have less than what we started with. I got this to work out to be 59.512, and our units are going to be the same as what we started with. They're going to be in milligrams. All right, hope this helps out. Good luck.